students, welcome back again on my YouTube channel, that is Alpha Classes. So student, today I have come with a new topic of class 12 physics of first chapter, and that is called electric charge and fields. So first of all, will discuss about some basics term, that is your electrostatics. So in the very first chapter we will dealing with some terms, that is your electrostatics. So first let us understand what is the meaning of the electrostatics. So the electrostatics means it is the basically a branch of physics that deals with the study of nature and natural phenomena. Basically it is all about physics. Now when we are talking about the electrostatics, so electrostatic is just a branch of what? Of physics that deals with the study of electric charge at rest. Okay, so in that case we will dealing with the study of the electric charge, and that charge is placed at rest. So if the body or if the charged body is placing at rest position, so whatever type of discussions or study we will dealing with, so that is your electrostatics. So this is the meaning of the electrostatics. Now if we will talk about the electric charge, okay, further we will discuss about electric charge. So electric charge is what? It's basically electric charge is an intrinsic property of a body. Okay, so it's intrinsic property of a body of any elementary particles which gives rise to the electric force between the various objects. Okay, so let's have a look. If a body contains, this is a object, or you can say body, metallic body, it contains a charge, number of charges are placed in it. So due to that charges, various forces are developed by the interacting two different objects or bodies. Okay, so whatever types of forces can be experienced by the two objects which contains a charge, so that kind of interactions between the two charged body is called intrinsic property, that is called charge. And that interactions or exerting a force due to these both charges, so that kind of charge is called electric charge. That's simple. So it is an intrinsic property of an object or of an elementary particles of any matter, okay, and that can be raised to the electric force between the two or various objects. So that is the meaning of electric charge. Now further we will see, or as we have studied in the previous classes, that electric charge, we have two types of charges. First one is your positive charge and negative charge. Okay, so we have two types of charges, positive charge and negative charge. So these are the two basic charges. Now with both charges we have studied about the both charges. Like a positive charge, whenever two positive objects or two positive charges comes closer, so it will get always reflect or repel to each other, so it will just get repel to each other. And when negative charge will comes closer, and they will also repel to each other, because we have studied a property gives a electric charge gives a property like both charges, like charges will get repel to each other, and if we will come closer with unlike charges, so that will attract to each other. So generally we can say, if positive will interact to each other, or either negative to interact to each other, or it will come closer to each other, so they will get repel always, okay. And if unlike charges are attracted to each other or come closer to each other, so it will get attract to each other. Okay, so these are the two types of charges, and that charges, whenever it will come closer to each other, so they will get attracted or they will get repelled to each other. Okay, so now let's discuss different types of materials which we have studied in the previous chapter, previous classes as well. So in this next topic we will see about the conductor. We will discuss about conductor and insulator. Okay, so first let's have a look on the conductor. So conductor is what? It is a type of material that conduct electricity or which can carry electric charge through it. Now in case of insulator, so it will not allow or permit it will not give a permissions to pass some electric charges through it or through them. Okay, so these are the two different types of materials. Now we will see basics properties of the electric charge. Now we have a three types of property. Now we have a three properties of. Now we will see what basic properties of electric charge. So we have a three properties. So first is your additivity, and second is your quantizations, and third one is your conservations. So let's see the about the first property, that is your additivity. So what is the additivity? Additivity in generally it's all the addition of the electric charge. Let's say if a body, this is your body or system, that system consists of number of charges, that means Q1, Q2, Q3, Q4, Q5 up to so on. So we have huge numbers of charges are placed in this. If we will see additivity, we will discuss additive property of electric charge. So here generally we can write it like total charges of the conductor or in the conductor is equals to Q1, Q2 plus Q3 plus Q4. This will go on up to so on. So this is nothing but the property of additivity. So basically we can see the number of individual charges which is present on any system, that will be combined or additions, that will gives a summations of all the individual, that will become your overall charges, means that given charges, and that is the property of additivity. Now let's have a look on the next one. So that is a quantization. So what is the quantization? See, listen, quantization is just electric charge. That means the total charges of the body is always an integral multiple of the basic quantum. Okay, so basic quantum of charges. So in that case, generally this Q will be equal to NE. This will gives a quantization. So what is the quantization? It is the number of integral multiple of one quanta, that means one electron. So in a one charge, that in a one charge there is a number of integral multiples of electrons. Okay, so number of integral multiples of electrons. So here the value of n you can represent it as plus minus. This will go on. Okay, and the n is here, in this case n is what? N is the integers. N is the integers. Now let's see the next property of the electric charge, that is the conservation. So what is the conservations? See, it holds in an isolated system. See, in an isolated system there is a charges, or total charges in an isolated system is always conserved, that means constant, fixed. Okay, so in this case conservations kya kehta hai, what does mean the about the conservations? So electric charges can neither be created and nor be destroyed. It will always changes changes into one form to another form. Got it? So this is the three types of property, basics property. See, electric charge is what? It is a scalar quantity. It is a scalar quantity, and its SI unit is Coulomb. Its SI unit is Coulomb. So now let's talk about Coulomb's law. So our next topic is Coulomb's law. Now see, the Coulomb's law, it states that the force of attractions or repulsions between the two stationary point charges is directly proportional to the product of the magnitude of two charges and inversely proportional to the square of distance between them. So this is the definition, or this is the statement of Coulomb's law. So as I can repeat again this statement, so it states that the force of attractions or repulsions between the two stationary point charges is directly proportional to the product of the magnitude of the two charges and inversely proportional to the square of distance between them. So what does mean? See, whenever the 2 point charges are placed, let's take Q1 and Q2 are the two charges, and they are separated apart a r distance. They are separated apart with r distance. So this type of force, it is a force. Let's take VC. FC. F stands for force, C stands for coulombs. Now it's state with the two different conditions. So first one is the force. It can be your attractive force or the repulsive force. So it can be attractive or repulsive of its magnitude, Q1 magnitude of its charges. So F is directly proportional to Q1, Q2. Let's take out first equations. Now second is inversely proportional to square of distance between them. So let's take out second equation. Now on the combining these two equations, so this two equations can be written as like this, and whenever the proportionality will come into the constant or equality constants, there must comes some constant, proportionality constants. So in this case, K is the proportionality constants. So Q1 Q2 over R square. So this is the statement of or expressions of the Coulomb's law or Coulomb's force. Here K is equals to 1 by 4 pi epsilon naught. In this case, this epsilon naught is called permittivity of free space. This epsilon is given by permittivity of free space. Okay, and this has the value is given by 9 into 10 to the power 9 Newton meter square Coulomb per square. So this is the this is a fixed value, constant value. K has a value which is 9 into 10 raised to power 9 Newton meter square per Coulomb square. Okay. Generally, it can be written as like this way also. Fc is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. This is your Coulomb's force. Okay.